Properties of logarithms. A logarithm is a form of an exponent. So that means that the rules of exponents are going to apply for logarithms. So if that's true, since b to the first power equals b, it would then follow that log base b of b equals 1. Now, since b to the 0 power equals 1, it would then follow that log base b of 1 equals 0. So these are two ways that we can convert basic exponent properties into logarithmic properties. Furthermore, a logarithm with a base of 10 is called the common logarithm. If no base is written for the logarithm, the base is assumed to be 10. So if we write log of 2 equals x, then that just means log base 10 of 2 equals x. So that's how we can generalize some logarithms. So let's do some examples where we're just thinking in terms of logarithms in order to help solve for x. So we have log base 5 of 125 equals x. So what we should be thinking is 5 to what power gives me 125? Well, if you think 5 times 5 is 5 squared, and that's 25, times another 5 is 125. So what that means is 5 cubed equals 125. Therefore, x equals 3. Next, we have log of 0.01 equals x. Okay, so recall that whenever there's no base, it's base 10. So we actually have log base 10. And we can simplify it further in remembering that this just means 1 over 100. So we have log base 10 of 1 over 100 equals x. So when we put it like this, then it's easy to look at it as 10 to the x power equals 1 over 100. Well, I know that 10 squared is 100. So if I flip the 10 squared to the bottom, that's using my exponent rules, which means add a negative. So x must equal negative 2, because 10 to the negative 2 power is 1 over 100. So x equals negative 2. Properties of logarithms are used to simplify and solve logarithmic equations. The product property of logarithms states that log base a of b plus log base a of c can be put together as log base a of b times c. As long as that a is the same, this works. The quotient property of logarithms is similar. It says log base a of b minus log base a of c can be put together into log base a of b divided by c. And finally, the power property of logarithms says if you have log base a of b to the c power, then you could write it as c times log base a of b. So you can bring the power up front. These are what we call the basic properties of logarithms. There's a few more we'll talk about in a little bit after some examples. Okay, let's do some examples of simplifying logarithms. The first one, log base 6 of 4 plus log base 6 of 9. If I look at it as log base 6 of 4 times 9, that's the same as saying log base 6 of 36. Well, now what I would be looking for would be 6 to what power is going to give me 36. Well, I know 6 squared gives me 36, so that means that my x equals 2. And that's your final answer. And the next one we have log base 5 of 625 plus log base 5 of 25. So this one, I would maybe work in two different parts. It doesn't really matter. You could multiply them together first, or you could work them in separate parts. So if we look at it as 5 to what power gives me 625, and then I add whatever that is to 5 to what power gives me 25. Well, I know 5 squared gives me 25, so y must equal 2. And 5 to what power gives me 625? Well, 5 squared is 25, 5 cubed is 125, 5 to the 4th is 625, so x must equal 4. So now I just have to add them together. 4 plus 2 is 6, so my final answer is 6. Next one, I have log base 5 of 100 minus log base 5 of 4. So this time I'm going to put it together, use the minus, so that means I'm going to divide, giving me log base 5 of 100 over 4, which simplifies to log base 5 of 25. And now I can think of it as 5 to what power will give me 25, and that would be x equals 2, because 5 squared equals 25. Next one, log base 7 of 49 minus log base 7 of 7. There's a couple ways you can do it. We know that we can put them together with division like we did the last one, or we can solve them separately and think of them like we did the one right above it. So if we put them together, sometimes that's the easiest way to do it. Log base 7 of 49 divided by 7. Okay, so in this case, 49 divided by 7 is going to give me log base 7 of 7. Okay, so now if you think of it as 7 to what power gives me 7, and that would be 7 to the first power equals 7, so x equals 1. And that's your final answer there. Alright, next example, we have log base 2 of 32 equals 6. So this one I'm going to think of as two parts. First, I'm going to bring my exponent up front. So I have 6 times log base 2 of 32. Now I need to figure out what that number is. So I'm going to look at that part right there as 2 to what power gives me 32. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So what that tells me is x equals 5. So now I have 5 times the 6. So 6 times 5 is 30. So your answer is 30. Next one, log base 4 of 16 equals 20. So again, you can use the power rule, bring the 20 up front, and we have 20 times log base 4 of 16. So I'm going to look at it as 4 to what power gives me 16. I know that 4 squared is 16. So that means that x equals 2. And now I can put 2 in for the log base 4 of 16, and we have 20 times 2, which equals 40. So your answer is 40. There's one last basic property of logarithms, and that is the inverse property of logarithms. This one's pretty simple. It says that if you have log base a of a to the b power, that's going to equal b. Or if you have a to the power of log base a of b, that also equals b. So basically, you can just cancel out as long as they have a common base, leaving you with whatever's left. So in this next example, log base 3 of 3 to the power of 4x plus 6. We can cancel out because we have common bases, leaving us with just 4x plus 6. And the next one, 10 to the power of log 18. Since there is no base, it's assumed base 10, so we can cancel them out, leaving me with just 18. And that's your final answer. Those are your notes over properties of logarithms. Go through some practice problems and make sure that you understand those before you take your quiz over logarithms.